Hi everyone, and welcome to another exciting show and tell presentation. In today's video, me, Hoang, and Bao would like to introduce the time series decomposition. This video focuses on the main ideas of time series analysis, the decomposition method, and will demonstrate this method through an example. Now, let's jump right into it. So, what is the time series? A time series can be understood as a collection of numerical measurements of the same entity taken at equally spaced intervals over time, such as yearly, monthly, daily, or hourly. For example, average daily temperature or daily power consumption of a household. It is important to note that the data collected irregularly or only once are not considered time series. With its definition being set, time series is a significant tool in many branches of statistics. First, the time series analysis can be used to understand how an event can change its feature over a period of time. Hence, the reliability, flexibility, and other important features can be predicted. Secondly, the cycle variations over a period using time series can provide basic understanding about the changes in a cycle quite effectively, which is very important when demonstrating business cycles. Thirdly, it can be used to forecast the future behavior of the data from understanding the past behavior by comparing the present trend with the past trend and analyze to estimate and prepare for the future trend. The time series performs better in predicting short-term trends as longer-term trends prediction have bigger uncertainty. Fourthly, the quality control process. The quality trend is predicted over time. People can evaluate current accomplishment and performances with expected performances to analyze the cause of variation as well as to find the causes of poor performances. In time series analysis, the time series can be divided into three main components, which are the trend, which are the long-term direction, the seasonal, which are the systematic and calendar-related movements, and the irregular, which are the unsystematic and short-term fluctuations. The trend can be defined as a long-term movement in a time series without calendar-related or irregular effects, and is the reflection of the underlying level. For example, this graph shows an upward trend over time. Next is the seasonal, which occurs when there is repeated behavior in the data at regular intervals. Next is the irregular component, also known as the residual of a time series, is what remains after the seasonality and trend components have all been estimated and removed, as in the two images here showing the components of the time series, which includes the trend, seasonal, and irregular. The functional form depends on the decomposition model. On what the composition model actually used. For example, this is the additive model and the multiplicative model, which TT, ST, and ET is the trend, seasonal, and the irregular component respectively. Next, Bao will discuss with us about the decomposition method.
Okay, so let's discuss about the composition in time series. So by definition, the composition can be as a statistical task in which the time series data is decomposed into several components, or we can understand it as extracting the seasonality or trend from a series data. Now, why should we use decomposition? So the time series decomposition can help us disentangle the time series into components that may be easier to understand and forecast the data. So by understand, we can figure out whether there is a trend or seasonality in the data. For instance, there might be spikes that are due to some drivers, but the spikes may not be visible because of the seasonality. So by decomposing the seasonality out, we will make the spikes stand out more visibly in the irregular components. and also it can help the forecast the future data. So one advantage of decomposition is that you can treat each component separately, then recombine them. So perhaps you believe that the trend should be dampened, or that the seasonality will change in some way, or there might be some conditional heteroscedasticity in the irregular components. So now let's see what does the technique do. So in time series data, the trend, the seasonality, and the irregular component are combined in two ways: additively or multiplicatively. So a rule of thumb for selecting the right model to represent our data is to see in our plot. So if the trend and seasonal variation are relatively constant over time or linear, then we will use the additive model. Otherwise, if the trend and seasonal variation increase or decrease over time, then we use the multiplicative model. So let's differentiate between the additive and multiplicative model. In the additive model, the variance of the data doesn't change over different value the time series, whereas in the multiplicative model, when the data increase, the seasonal pattern or the variance also increase. Besides, the additive model is a linear model, which the trend line is a straight line and seasonality has same frequency and amplitude, while the multiplicative model is a nonlinear model, with the trend as a curved line, for example, an exponential or form or quadratic form, and the trend is a curve, and the seasonality has an increasing or decreasing frequency and amplitude over time. Now let's discuss about the the classical decomposition method. Besides this method, there's also other way to decompose the function, but now we only have time to discuss this most basic procedure. So the first step is to estimate the trend. There are two different approaches could be used for this task. One approach is to estimate the trend with a smoothing procedure, such as moving average. With this approach, an equation is not used to describe the trend. The second approach is to actually use an equation by modeling the trend with a regression equation. The second step is to dechange the series for an additive decomposition. This is done by subtracting the trend estimating from the series, and for a multiplicative decomposition, this is done by dividing the series by a trend value. Next, the seasonal factors are estimated using the dechange series. The simplest method for estimating these effects is to average the descended values for a specific season. For instance, to get a seasonal effect for January, we average the descended values for all Januaries in the series and so on. The final step is to determine the irregular component. For additive model, the irregular component is equal to the series minus the trend and minus the seasonal, while in the multiplicative model, it is equal to the series over the trends multiplied with seasonal.
So now we will try to apply the time series decomposition technique to analyze the fluctuations of number of air passengers over time. And in this demo, we will use stat model, a library for data processing and analyzing developed in Python. And there are still some other libraries and languages like R or MATLAB you can try to explore yourself. So the first step is that importing the important package, and after doing this, important package and the data. And after doing this, we can have our first look at the data through the graph. Yeah, as we can see here, although there's a very quite very obvious increasing trend in overall, the number of passengers still experience many complicated fluctuations that are quite typical for us to analyze and explain if we just look at the unprocessed time series. Or in other words, the time series data has been the time series data that has been decomposed give a very little information. To make it easier for us to draw the inference or make the predictions, we can decompose the time series into smaller components, including trend, seasonality, and residuals. And here's we use season decompose function. After being processed, the time series component can be represented at the figure shown below. And look at the trend component. We can see that the passenger tend to increase years by years, just as we had commented earlier. And in addition, the seasonal component also show that the number of passengers change according to each time of the years. These fluctuations reflect the change in air travel demand during the year. And finally, the residual component represent the noise in the data, or possibly the factor or the pattern in the data that has not been considered. And obviously, considering each element in the data gives us more information, thereby making it easier to make the inferences. And the data scientist or analyst or expert can link these fluctuations in each component with the real event to provide the clear explanation. Specifically, in this example, the variation in years to years can be the variance of number of passengers during a years can be explained by the increase in the travel demand during the tourist seasons. And yeah, as we can see through the presentations, time series decompositions is a very useful technique in data processing and analysis. Breaking the time series data into smaller components make it easier for us to observe and see the patterns for the data's fluctuation. And with its usefulness, the time series decompositions is widely applied in many fields, such as economics, finance, and even the scientific research. Okay, so that is the end of our presentations. Thanks for your attention. And if you have any questions, please contact us and send it via email.